All right, so it says write the equation line in standard form passing through the given point with the given slope. And so from what we've learned so far, we given a point and slope, the best thing to do is to go to y equals mx plus b and get some form of the equation and then convert it to standard form at this point. And we're going to learn a new equation in this section, but from what we've learned so far, we can just start with y equals mx plus b. So for what they have given us, they've given us x, y, and m. So we have x, we have y, we have our m. Now remember, if they give you 0 and a number, that is your y-intercept. So this one was kind of easy. You didn't actually have to solve for b. They actually handed it to you. 0, 8 was your y-intercept. So that is b. So you can start with y equals mx plus b. All right? And they want it in standard form. So standard form, if you'll remember, is ax plus by equals c. So in standard form, we need to move that x over. So if I move it over, I'll have negative 1/5 x. Remember, if you go across the equal sign, it changes the sign, plus y equals 8. Now, I do not want fractions at all, and I do not want my x to be a negative if it is in standard form. And so to get rid of the fraction, I would multiply everything by 5, because that's my denominator. And specifically because that happens to be a negative in front of my x, I'm going to multiply everything by negative 5. So I'm going to multiply this by negative 5, that by negative 5, and that by negative 5. All right. Once I do that, I will have this in standard form. So my negative 5 and 1/5 will cancel out to just 1. Negative 5y and negative 5 times 8. So when you did this one, you would have gotten 1x minus 5y equals negative 40. Equals negative 40. All right. Now this next one did not give me my y-intercept, okay? They gave me an x and a y, but they didn't give me my y-intercept. So I actually cannot just get the equation of this line without solving for something. For this one, I actually need to solve for my y-intercept. So I am going to put it in y equals mx plus b. Again, they gave me the y, and the x, the y, and the m. So I'm going to say y equals mx plus b, right? And I know these two, so I'm going to say 0 equals m times x plus b. All right. When I do this, I get 0 equals 27 over 4 plus b. And you can see that b is going to equal that negative 27 over 4. So this one's not very pretty, but that's okay. It will all work out. Negative 27 over 4. So now I can at least write some form of this equation. I can say y equals mx plus b, b being the negative 27 over 4. All right, so again, they want this in standard form. So I'm going to move my x over. I'm going to move this over, so that's going to be a negative 9/4 x plus y equals negative 27 over 4. Again, I do not want any fractions, and I specifically don't want my x to be negative for standard form. So my denominator is 4. I know I'm going to multiply everything by 4, but again, I'm going to multiply everything by that negative 4 to get rid of it with my x. So I'm going to multiply that by negative 4, that by negative 4, and this by negative 4. Right here, all this does is it gets rid of my denominator and my negative. So I have a 9x. Here, negative 4 times y is just negative 4y. Here, it gets rid of my denominator and actually gets rid of a negative there as well. So in standard form, it is positive 9x minus 4y equals 27. And this is your answer for that one. So the first thing they remind us of is the definition of slope. Remember, to find slope, you're going to subtract your x's and put that over the subtraction of your y's. So in this case, instead of using 2 points, they're going to use a generic point on the line xy and then a specific point on the line x1, y1. So they subtracted their x's, they subtracted their y's. Now this next step is what they did is they multiplied both of these by this group. So they multiplied this side over here by that group. And they multiplied the right side by that group. So we multiplied this side by this group. And they multiplied this side by this group. So they just took the slope formula and they multiplied both sides by that group. On the left-hand side, it cancels out. On the right-hand side, you just have it multiplied. And you end up with this equation. Y minus y1 equals mx minus x1. That is the point slope form of a line, all right? Y minus y1 equals m times x minus x1. That is called point slope, all right? And so often this is used anytime you have a point and the slope makes sense, right? And so if you look at the first example, we have 2 points. We don't have the slope, but we can find the slope anytime we have 2 points. So for this first example, they've given us a line that passes through negative 5, 2 and 3, 4. And they want it in 2 ways. They want it in slope-intercept and they want it in standard form, all right? So the first thing we are going to do is we are going to find the slope. So to find the slope, we're going to subtract our y's. 2 minus negative 4, that's my y's. And we are going to subtract our x's. Negative 5 minus 3. We get 6 over negative 8. Reduce that, we get a negative 3/4. So that is my slope, all right? When we do point slope, we can use either point. It does not matter. They used the point 3, negative 4. But we could also use negative 5, 2. You will get the same equation, all right? So if I use the point that they used, I am going to do my point slope equation. Y minus y1 equals m times x minus x1, all right? You notice I don't have a b. I only have really one point that I'm going to fill in for here and here. X1 and Y1 are the point that I'm choosing. And I have my slope. That's what I'm going to fill in on this equation. The point, the X1, Y1, and the slope. The other things are going to remain variables. So this is going to stay a variable, and that is going to stay a variable. All right? So I'm just going to fill it in with the 3, negative 4 as my slope, as my point, and negative 3/4 as my slope. When I do this, I will say y minus my y value of the point equals m times x minus my x value of the point. All right. They want it in 2 ways. They want it in slope-intercept form. So I'm going to simplify this piece, and then I'm going to put it in slope-intercept form. Over here, I'm going to simplify with a plus, right? Minus a minus. Well, that's just plus. Over here, I'm going to distribute my fraction. Negative 3/4 times x and negative 3/4 times negative 3. All right? So from this point, I can decide what I want to do. Do I want to put it in standard form? Do I want to put it in slope-intercept? They said do it both ways. So the first thing is to put it in slope-intercept form. Well, that is y equals mx plus b. So to use this and to put it in slope-intercept, I'm just going to move that 4 over and subtract it from my like term there. Okay, because then I'll have the y by itself. That's all I need to do to go from here to slope-intercept. Subtract my 4. On the left-hand side, I will get my y all by itself, which is what I want to do. My slope doesn't have anything that's affecting it, so we're just going to say negative 3/4 x, right? And then I need to combine these two. This is a 4 over 1. What do I need when I'm adding fractions? Common denominator. So I'm going to multiply both of those by 4. So that's going to be negative 16 over 4 that I'm adding. Positive 9 and negative 16 will give me a negative 7 over 4. That is slope-intercept form. So I have answered that piece of the question. Negative 3/4 x minus 7/4. That's slope-intercept form. I've answered that, okay? They also want it in standard form. Well, now I'm going to do exactly what I did for my bell work, okay? If we had gone standard form first, we would have had to move the 3x over and the 4 over. But we've already done that. We've already done the 4 over. So now we're just going to go from my slope-intercept, and I'm just going to move that x over. All right, it's a negative 3/4. So when I move it across the equal sign, it becomes a positive 3/4. I have a plus y equals negative 7/4. All right. In standard form, what do I have to get rid of? My denominator, and I need to make sure my x is positive. All right, my x is already positive, so that's fine. What do I need to multiply everything by to get rid of my denominator? The denominator that I have, which is 4. So I'm going to multiply every piece of this by 4. Right here, the 4's cancel. I just have 3x. 4 times y gives me a 4y. Over here, the 4's actually cancel, and I'm left with just negative 7. And that is my standard form of the same line, all right? The same line. So those two lines, if I were to graph them, so let's say I were to graph this, I would start at negative 7/4, go down 3 over 4. I would get a line that looks just like this guy if I did an x-intercept of negative 7/3 and a y-intercept of negative 7/4. They would look identical because they are the same line. They're just written two different ways. All right? So parallel lines are lines in the same plane that have no lines in common. So if they're in the same planes, they will never intersect. You've seen parallel lines. You probably use them in pre-algebra worlds. All right? Perpendicular lines, they do cross, and they cross specifically at 90 degrees. Okay? So parallel lines never cross. They're on the same plane. Perpendicular lines cross at a 90 degree. All right? And so they've given us some parallel lines. A, B, and C are all parallel. You can see that visually. And then they have told us what the slope is. What do you notice about the slope?
It's the same.
It is the same. But what do you notice about the y-intercepts? Those are different. All right? So anytime two lines have the same slope with a different y-intercept, they will be parallel. And it makes sense. So if I start here and go up to and over 1, it makes sense that if I start here and go up 2 over 1, it's going to be a parallel line because they're going to be, the slope is going to be the same. All right. And we're starting from a y-intercept here. All right. So it makes sense that parallel lines have the same slope. All right. So that is the first thing we're going to learn about parallel and perpendicular lines is that all parallel lines have the same exact slope. All right. So the first thing we're going to do is just give two lines and we're going to decide if they're parallel. Determine whether the lines described are parallel. What form are these in? Well, these are in standard form, all right? In standard form, you can't automatically look at it and decide what the slope is, all right? In standard form, the slope is not the guy in front of the x. So we need to put these in slope-intercept form so we can look at these lines and figure out if they are parallel. So we're going to take the first one. We're going to say 3x minus y equals 6. We are going to put this in slope-intercept. So we're going to move this over. Negative y equals negative 3x plus 6. And then my last step is to divide everything by negative 1. What's in front of my y? So this slope-intercept looks like this. 3x minus 6. Let's look at the other one. Negative 9x plus 3y equals 12. Our first step is to move our x over. We have 9x plus 12. And then our last step is to divide everything by that 3. Y equals 3x plus 4. First thing, do they have the same slope? Yes, the slope here is what? 3. Do they have the same intercept? No, then they are parallel. They are parallel. All right. So these lines are parallel. So they have to have the same slope and different y-intercepts. Why different y-intercepts? Well, if they start at the same point and have the same slope, they're not parallel. It's the same line. Okay, so if they're not going to be parallel anymore, they're actually going to be the same exact line if they start at the same point and have the same slope. So that's why you're checking your y-intercepts, because they have to start at different points to be parallel. Nope, not yet. So this is very similar to what we did with example 1, all right? Example 1 told us to take 2 points and to write the equation of the line. But anytime you write an equation of the line, you need 1 point and the slope, all right? If you're given 2 points, what do? You find the slope and use a point. So this is telling us this line is parallel to this guy right here. The only thing we need to know about that line that they've given us is what the slope is. Because to find the equation of the line that has the same slope as this and goes through that, we need to know what the slope is. So I am going to take this right here over to the side, and all I'm going to do is figure out what the slope is. So I'm going to move my x over, and I'm going to divide by the number in front of my y. Here's the thing. I actually don't care at all about the y-intercept here, okay? What I care about is the slope. They want it to be parallel. We just said all parallel lines have the same slope. So they could have said, write the equation of the line passing through this point with a slope of -4/3. Or they could have said, write the equation of the line going through this point that is parallel to this. It means the same thing. They could have just as easily said it another way. All we need is a point and a slope to find the equation. So they gave us the point, -5, 9. All we did was we used this line to figure out what the slope is. That's all we care about when we look at that line that it's parallel to. So now we have a point and we have our slope. And now we can write the equation of the line. And we are going to use our new form, point slope. So we're going to use the y minus y1 equals m times x minus x1. All right? And we're going to find the equation of the line. We're going to say y minus our y value equals m x minus our x value. All right? Over here, minus a minus is the same thing as plus a 5, right? It's plus a positive. So I'm going to distribute my -4/3. Right there, distribute my 4/3. And then my last step is to add my 9 over. All right, what do I need? A common denominator, right? This is 9 over 1. What is my denominator? So this is going to be 27 over 3. So I have -20, positive 27. I'm going to get y equals -4/3 x plus 7/3. So parallel lines have the same slope. That's what we've been doing. Perpendicular lines have slopes that are negative reciprocals of each other. Okay? Reciprocal, that just means to flip it upside down. Negative just means change its sign. It does not mean it will always be negative. It means it's opposite of whatever the other line was. Okay? So parallel lines are the same. Perpendicular are negative reciprocal. In your book, it has this little crazy thing. Negative reciprocal of a number, you just flip it and change the sign. So really quickly, we're just going to go through what negative reciprocals look like. All right. So if I am given 8/5, the negative reciprocal, I would change this to 5/8. It was positive. I would make it negative. Negative reciprocal of 9. Think of it as 9/1. So the reciprocal would be 1/9. It was positive. I would make it negative. The negative reciprocal of negative 13/7. Flip it upside down. 7/13. It was negative. I would make it positive. That's what you do to find the negative reciprocal. Flip it and change the sign. All right. So if I said this line is parallel to this line, you're going to use the slope exactly the way it is. If I say the line is perpendicular, you're going to take that slope, flip it upside down, and change the sign. And then you're going to go back and use point slope. And that's what we're going to do here. It says write the slope intercept of the equation of the line perpendicular to this line and going through this point 2,7. So I'm going to take this line that they've given me, and they are telling me it is perpendicular. The only thing I care about is the slope. All right? The slope of the line they gave me is -4, but I need a perpendicular line to that. So I am going to take that and I'm going to do the negative reciprocal. Think of it as -4/1. I'm going to make it 1/4 and I'm going to change it to be positive. So this is the slope of the line I am trying to find. Okay? And then I'm going to go right back to point slope. So I have my slope now, and they gave me my point, and I'm going to do exactly what I've been doing. I'm going to say y minus the y value here equals mx minus the x value. And then I'm going to do what I've done the whole time. I'm going to distribute my slope. And then I'm going to move that y over. And again, you need common denominator. So this is going to be 14/2. All right. And then we need to add -1 and +14. So we're going to get 13/2. So we have y equals 1/4 x plus 13/2. All right. So over and over, you're going to see the use of this point slope. They're going to say things like, here's a point and the slope. Give me the equation. They're going to say, here's 2 points. Give me the equation. Find the slope. Use one of the points with point slope. They're going to say, here's a point and a parallel line. Use the slope that you have from that line and your point. They're going to say, here's a point and a line perpendicular. Use the negative reciprocal as your slope and the point that they gave you. That's why this point slope equation helps you so much, because you can use it with a lot of these. All right. So I want you to try some of these. The first one, give me the negative reciprocal. State the slope of a line perpendicular. And then I want you to actually find the line that is perpendicular to that line. So you can take any two lines, and if you find the slope, you can figure out, are they parallel? That means the slopes will be the same. Are they perpendicular or neither? They just intersect some other way besides 90 degrees. And all you have to do is you just find the slope. So the slope of this guy is going to be subtract and divide. By the way, it's always going to be the negative in front of the x over the y. If you haven't figured that pattern out, your slope in standard form will always be the negative coefficient of x over the coefficient of y. This guy is going to just be -4. Standard form is ax plus by equals c. Your slope always ends up being -a over b.